Biomagnification. This is probably the most important topic you will learn in your life. And it's not me being dramatic as a teacher going, oh, this is my field. They're going to love this. My field is physics. This topic, though, is so important and is not acknowledged enough by our leaders and politicians. It's on a scale that people have trouble imagining what's actually happening here, and it threatens the entire planet. You're going to be able to tell me what a persistent toxin is, fat soluble and water soluble toxins, and how they can accumulate in the body. And we have to put the death to the old phrase, dilution is the solution to pollution. Pollutants released at even tiny levels can cause danger over space and time at a level that is beyond comprehension, and thus, for a lot of people, unbelievable. The basic idea is energy and biomass decrease as we go up the food chain, but persistent chemicals increase, the ones that persist in fat. So compounds like lead, arsenic, mercury, they can grow in levels on the food chain until they are millions of times higher in the top predators than they were at the beginning. In fact, they can be so low in concentration, they are undetectable in the environment, yet we find them in human livers. Water-soluble items like vitamin B, sugar, they break down. They get taken apart by the body, used elsewhere, urinated out, and so the predator does not inherit any of those things. One of the distinctions, I guess, in the old WIMA system is poison versus toxin. Poisons were things that killed quickly, like cyanide, and toxins are things that kill you slowly, little bit at a time as they build up in your body. So they've gotten rid of these two WIMA symbols, but I really like them. P was like pirates. The death is quick. Arr there, Billy. We're going to make you walk the plank. You'll be dead in a moment. Pirates, swift, like poisons. This symbol for toxin always struck me as it was a letter T for time, drop by drop. But it also struck me as another apt metaphor for a slow, long, accumulated death. Arr, Billy, forget about the plank. We're all out of planks. We're going to have to kill you with thumbtacks. You'll need to be patient. It's going to take a while. Why toxins are more dangerous than poisons? If you drank something and immediately began to vomit blood or have convulsions or felt like you were going to die and you survived it, you would know what happened and you'd stop. If you're working with a chemical and it's so immediately overpowering an odor, you put your safety equipment on. But if you were working with, say, lead-based paint, and year after year you skipped wearing your respirator, and you just were like, so what? Big deal. I don't feel nothing wrong. I'm fine. You retire, and 20 years after you retire, your memory's going, you're getting the shakes, you're sick all the time. You'll never make the connection to all those years of painting with a lead-based paint. So the toxins are sneaky because they accumulate till you get to a poison dose. The trick is, for a toxin to accumulate, it must not biodegrade. It goes in your body and stays there. So, for example, bee stings and booze. If a person's drunk and mosquitoes bite them the next day, the mosquitoes do not get drunk. If you were stung by 100 bees and then a lion ate you a month from now, the lion accumulates no bee stings. Okay? But lead and other toxins will build up. So let's suppose a lion eats a deer. The lion inherits none of the deer's bee stings, but what if the deer had 50 milligrams of lead in its body? It built up over 10 years of living on grass that had been sprayed with a chemical. When the lion eats the deer, it gets all 10 years of lead dose in a single meal, and that can have devastating consequences on the lion. As humans, we are at the top of the food chain, and we bear the highest burden of bioaccumulation. The problem here is ecologists couldn't make up their mind on the term, and there are three ridiculously similar terms that can cause some confusion. Bioaccumulation is what you do when you eat things. Your body sifts through it, and the fat soluble stuff doesn't come out of you again. Bioconcentration occurs if you're a water dwelling creature and you're basically soaking in the lake. And whether you eat toxin material or not, you're soaking in the water. Biomagnification describes what happens when the lion eats the deer. It's the concentration of the food chain. They really should have picked different terms. If I had my way, I would have called it trophic concentration, hydroconcentration, and bioconcentration. So you got the idea it was concentration in a body, in water, or between food levels. I will use the terms indiscriminately. The textbook and websites tend to be nitpicky. So I'm not testing you on these three terms. I just want you to be aware of these three terms. So we'll pause for part 2.